Okay guys, so let's just have a look at what I was talking about to do with standard deviation last night in the lecture. If we go down roughly to slide number, was it 32? Yeah, there we go. I had a few numbers. What we'd like to do is get some information about this. So previously what we've been able to do is get something which describes that set with one number, roughly giving us a position of where that is of all numbers. That is the mean, the average. We can also use the median, so the middle number, or the mode, which is the most common. We've also got another tool in our data set now, in our toolbox effectively, which allows us to describe how wide the actual group of numbers is, and that's known as the range. But now we've actually got a way of being able to describe if most of the data points are pretty close to the center or quite far away from the center. In other words, if most of the numbers are somewhat spread out in the case of B, or if most of them are pretty close to the center like in A. And that is called standard deviation. So let's give it a go. Here we go. So this is all of our numbers. Alright, cool. What we want to actually be able to go and do is apply this really neat equation right here, this one, to what we're doing. I'm just going to leave that now in the corner somewhere here for you guys to be able to see. Wicked. In fact, you know what? I'll just leave it below. Here we are. So the first step that you want to be able to do is what's inside the brackets. So what we do is we have our value, which is x, and we take away from that value the average. We do that to each value. Okay, so here we go. Let's get the average, which is also known as mean, equals, and then average, brackets, the number. And then you can close the brackets or just hit enter, doesn't matter. But that just only gives us an average of that number. If we instead extend this, we can get the average of all the numbers that we've selected across. There we go. So that's our average. What we can then go and do is go and get the average, just literally bring that down for all the numbers, just for example's sake. Watch this, and watch what happens, and it's not going to work. Oh boy. So the average seems to change in each case, and I'll tell you why. When you go and apply a function like this to a particular cell, like I did, so this is it, okay, when I go to the next one, it'll apply that same thing relative to that box in the same way. So I need to be able to lock it, okay? I need to be able to tell it to keep the box starting and finishing at the same point. So what I do with that is just simply tell it, well, I want to keep it where it starts is here, this box. I want to tell it that I want it to stay in column C, and that I want to tell it to stay in row 6. Now when I extend it, it's effectively gone and applied that same idea as before, further and further down. So I want to also be able to tell it that I'd like it to finish at the same point. And I do the same thing to the end with that dollar symbol. Boom. Now if I do that same trick, it's going to be the same value, and it's always keeping that box in the same place. So now what we've gone and done is collected the average for that data set. So we've got this value, the green one. Alright? The next thing that we want to do is take that away from each number. So let's do it. X take X bar equals X take away X bar. Enter. And then we just extend it. So here we go. It's done it there, it's done it here, and it's gone and done it here as well, which is excellent. So we've got each one of these values now worked out. The next step is to square it. Now the important thing that you need to know, and the reason that we square, is to make sure all of the values are always positive. So let's go and square everything. X take X bar squared. That's what this is going to be about. And this is how you do squared in Excel. If you want cubed, it's hat 3. So that is, I believe on your keyboard, in my case anyway, shift and 6. So watch this. Equals that number, shift 6, and then squared. Enter. Boom bam. And you can do this to each and every single number. So it goes and applies that same idea to every box below. Cool. So we've now gone and figured out this one for each and every single number. The last thing is to get the sum. Okay? So remember, the sum is of everything else that's collected, or sorry, every other data point in a particular set. Okay? So equals the sum of everything. Enter. We've now gone and collected that sum. The next step is to go and divide it by the number of values, sum over n. So what we know is that there was one value, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values here. Okay? This one was the first, second, and third, all the way through to the 11th. Equals that, and forward slash is divided by. Forward slash is shift. No, it's just next to the right shift key in my case. And then you say what you want to divide it by. And that is 62. It works out to 62. Good. Finally, the last step is what everything else is inside of, which is that square root. Now, the way that you do this is square root. That's how Excel works. So you go equals square root of what you're looking to square root. And you say enter. Now, we've actually gone and calculated S. So this is your standard deviation. Weird. You've just gone and calculated the standard deviation for this set. Let's go and do this now the quick way. How do you do all of this in one step? Well, here we go. The quick way. And SQW doesn't actually exist in mathematical literature. I'm just keeping it there so that you can see that this is my quick way example. And the way that that is done is using an equation called STDev.P, the standard deviation of your population. So you go equals STDev.P, open up your brackets, and what you want to get the standard deviation of. In the same way that this gives the standard deviation of that set, you want to do the same thing to that set, just using that one equation, and hit enter. By Jove. There you go. You've just now gone and calculated the standard deviation for all of these numbers in two different ways. So this shows you the process of actually applying it one step at a time in each case, going from the first step through to the last one to give you your standard deviation right here. This shows how to do it quickly. So in future, when you get a set of data, and as long as it's, remember, normally distributed, so like that, and not skewed, then you'll be okay. You can effectively go and say that in my example, if these numbers described ages in a group, you can go and say that the average age of this group was 30.9 years of age, and that 68% of the whole population, so roughly 68% of all of these numbers, are 7.8 years in any direction. So let's test that out roughly. And it won't be perfect because you haven't got a very large data set, but we can still do it. So for example, if 68% of the population is supposed to fit into this, what that therefore means is that my average was 30.9 roughly, which means the maximum value that that 68% can go is equal to that value, the average, plus our standard deviation in one direction. In the same way, the minimum value that the standard deviation can take is that value, take away that standard deviation. So now, if I just do that really nifty thing of applying some formatting to take away a few decimal points, the maximum age that 68% of the population can fit into is roughly 9 years of age, and the smallest is 23. So does the age 15 fit? No. Does the age 21 fit? No, it doesn't. Does 29 fit? Yes, it does. 30? Yep. And this carries on through for a little while. So 33 still fits in because the 38 is the maximum that can be. Does 42? No. Does 45? No. Here we go. So this was our rule right here. What we found was that these people with these ages fit into that 68%. These were on either side of that 68%, so they were not included. Now watch this. Let's find out what percentage of the population is within that standard deviation. So we know that 7 people were fitting inside out of 11. So here is the percentage. Here we go. 7 out of 11. So what you say is equals 7 out of 11, and I want to know that it's a percentage, so I times it by 100. And the times by 100 always stays the same. Roughly 63%. So I'm going to say about 64% of the population. How cool is that? Now the reason that it's not 68 is because you simply don't have enough numbers. 7 divided by 11 is not the same as 68 divided by 100, or if you had 200 people, so far, so it just continues to increase. But 64 is a pretty good example of how close it can get. Not bad, eh? So there you go. That's within one standard deviation. Right here. Where is he? They fit into this group. One standard deviation. So guys, that's how you do it. Now you have a tool of knowing how spread apart this is. So for a population which had ages which started earlier and finished later, the spread is wider. And you can describe that using the range. But knowing exactly the shape of this curve is done using standard deviation. And it would increase, this would increase for a population that's wider. So let's say starting at 1 year of age and finishing at 90. This would be greater. Alright, I hope that explains standard deviation to you guys, and I wish you all the best. Last night's lecture was definitely supposed to be just a strong basis for being able to grip standard deviation, and then I hope the tutors managed to complete the picture and explain to you the finer details of it. The thing is, standard deviation is really complicated, and to be able to understand it in 2 hours is phenomenal. So I hope that arms you with the sense of success in some ways, or hope in others. Ladies and gentlemen, send me any emails, send me anything on Flow, and I'll be more than happy to answer all of your questions. Thank you, and take care.